Hi, and welcome back. In this lesson, we're going to be covering controlling and monitoring access using the CISSP Chapter 14 from the study guide. If you're following along with our lesson, we're going to be doing controlling access for this lesson, and then our next lesson to finish out our software assurance is going to be on assessment and testing, including vulnerability assessing. Let's get started. Our first section is going to be on comparing access control models. It's really important for you to understand the different models that we use to compare our access controls. So let's start talking about rights versus privileges, and then we'll go into authorization mechanisms, security policies, and then the individual control models themselves and what each of them means. So first, a right versus a permission. So technically, the way we look at it is a permission is specific access that is granted for an object, including read, write, and execute. Essentially, what access is given for that given object. A right is the ability to take action on an object, such as to modify it, restore it, or delete it. So if we are going to do something specific rather than simply reading, writing, or executing, those are called rights. Privileges are considered a combination of both, such as full privileges, which could be any action or any access. We could have read-only permission, where you have the permission to read, but don't have any rights to take any action on those objects. So a privilege is kind of a conglomerate term that we use to easily describe a combination of permissions and rights. Sometimes you might have the ability to modify without having the ability to delete or restore, or you might have the ability to read and write, but not delete. So different possible options for privileges, which would be a combination of both permissions and rights. When we want to start thinking about our authorization mechanisms, and there's a few of them, so I have a couple of different slides that describe about 2 of them per slide. The first authorization mechanism we refer to is simply an implicit deny. Everything is denied. Start from that point. Everything is denied by default. Then we start explicitly describing things that are allowed. So if I'm going to explicitly allow a specific port to be open or a specific IP address to be allowed in, I can permit certain rules, but everything else is denied. So an implicit deny is a pretty safe way to start because you're actively only using what we would call whitelisting to be able to describe the individual things that you want to give permission, and anything not on that list is denied, straight out. Another option we have for an authorization mechanism is an access control matrix. A matrix, or an ACM, is a table that includes the list of subjects down one side, the list of objects across the top, and then the cell in between that subject and that object is what is the permission for that person for that object. So each individual object essentially has its own access control list that says John is able to read and write, whereas Mary is only able to read, and Susan is able to read, write, and execute for file A. So different permissions, and for printers you could have yes or no, yes it can access it. For individual folders, you can have no rights at all. So individual access control matrix includes the subject and the object and the individual permission. Another type of mechanism is our capability tables. Capability tables focus specifically on the subject, broken into users, groups, or roles, and then being able to say what is the individual role and what are they allowed to do. So we can break it into the individual subjects and what are they able to do with a capability table. A constrained interface is where we actually modify the interface based on permissions that are granted. So, for instance, if I am the admin, I can see and do everything. Whereas if I am only in sales, I can see current customers, I can submit orders, so I can actively submit orders or see the current customers, but I can't see non-active customers, and I can't approve orders, but I can submit them. So individual rules based on what is your role or what is the individual privileges for this given user. So a constrained interface means that we're changing the interface around based on the privileges of the user that is currently using the system. It's kind of a nice thing where you can have one system that's completely used by every customer, and yet based on who the customer is, the customer can only see his orders. He can't see everybody else's orders. He doesn't even know that there is a button that says change my blankety blank piece of information because he doesn't have the ability to do it anyway. So it limits the ability for hackers to go in and just start clicking admin buttons and, oh, darn, I can't access that. If they can't see an admin button anyway, they don't know that it's there, it decreases the chance of them being able to use it. Another authorization mechanism we use is content dependent. This is where we restrict the access based on the content of the object. We do this sometimes with databases or with interfaces where an individual person may be able to see another employee's name, maybe their phone number, but they wouldn't be able to see another employee's salary. So that may be blocked out. Maybe date of birth is blocked out. So if it's a specific PII, personally identifiable information, or if it's some other piece of information that we don't want available to the public, we can simply block it out or mask it in some way so that it isn't available. So and we can also take content dependent and make it where we don't even show specific columns from tables. So being able to change around what you can see, what you can view based on what is the content. Compare that with context dependent, which is where in context dependent, it means something has to have occurred prior, such as a date or time, perhaps logic controlled. The example that we have here is that you have to add items to the cart before you can check out. You can't check out until you have added items to the cart. You can't process the payment until you've done the checkout. And you can't actually download the new item you just purchased until the payment has cleared. This is a context dependent. The download item screen won't even show up unless the process payment screen has already been processed. That one won't show up until you've gone through checkout. So we limit what you are able to visualize or do based on the context or what prior actions have occurred. The last three are kind of related to each other. First, we always want to follow a need-to-know basis. Employees should only have access if they actually need the access. There is no reason for me to know the salaries of my coworkers. I don't need to know that. However, if I'm in HR and I have to process paychecks, okay, now I need to know it. So unless I need to know a certain piece of information, there is no reason to give me access to it. Make sure that employees, do not have access to objects that are not part of their regular duties. Following that same concept, ensure that employees only have privileges that are required to do their job. This is where the concept of privilege creep comes in. If you end up switching from job to job or task to task or moving from one project to another, you may end up getting some extraneous privileges, and then when you change the project, you're no longer on it, you don't need those anymore. But that takes effort to go in and remove those privileges. We call that privilege creep. Being able to have the privileges from a previous project that is no longer appropriate. This is where the concept of making sure you audit your privileges frequently and make sure that you check employees that they don't have extraneous privileges anymore. Along the same line is the concept of separation of duties, simply ensuring that sensitive functions are usually split into tasks that are completed by at least 2 employees. This decreases the chances of collusion where multiple people are all in on the same fraud. One person, they can easily pull $20 out of the till and nobody notices. But if I have to get a secondary approval on getting an invoice paid, then it's really hard for me to just cut a check to myself for $100,000 and have the company sign off on it if I'm also the signer. So we want to make sure we separate out company or sensitive functions into tasks that have at least 2 people. Back when we used to write paper checks, you might have to have 2 signatures on a check. Same concept. Your security policy is an artifact that identifies the requirements within the organization. It lets everybody know what security solutions are implemented. It can be based on the entire company or department or area specific. So the policy should always be in writing and making it very clear to those that need to know what the policy is for security. Your intent is always to ensure that all of your personnel understand the security requirements. However, it doesn't generally give individual details on how to implement that policy. You want to make sure that those kind of things are still somewhat private, just in case that document gets out. It's used more of as a guide to make sure that you end up hitting all of the main points, but it doesn't tell you exactly how you are going to do those. At this point, we're going to start describing some of those control models that might be used in companies that you go to. The first is probably the most common, called Discretionary Access, or DAC, Discretionary Access Control. The way discretionary access works is every individual object has an owner, otherwise known as the data custodian. The owner has the ability to grant or deny access to any other user. So if I have a file, I own it, I can choose to give access to other people in my company, to people that I work with, colleagues, and I can choose not to. So individually, I, as the data owner or data custodian, have the right to grant or deny any access. The owner makes the decision, and you can do this either as individual users or as groups or roles. This is the technology that is used in NTFS systems in Windows. So when you do an NTFS system that uses directory access, you are giving individual items the control to the owner, and the owner or data custodian gets to decide who can and cannot use, read, write, execute, so on and so forth. Mandatory access or mandatory access controls, MAC, use labels for both the subject and the object. So if I give a subject, a person, the label of top secret, and I give this file the label of top secret, then they can both access it. So that subject can access that file. However, if the subject is not top secret, but the object is, then he can't have access. So the user and the subject must have matching labels. We sometimes call this a lattice-based model because we build things up. We can choose in mandatory access to have one of three different types. The first would be hierarchical. Classification is in an ordered structure from lower to higher. The higher can see objects that are in lower classifications, but not vice versa. Obviously, if you are down at the public, you don't want to have access to confidential. But if you have confidential access, you can also see things that are public. Basic hierarchy. You can also choose to have what we call compartmentalized. There is literally no relationship between the different domains. If you are in the Crimson group, you have no relationship with either the Matterhorn or the Sleuth group. Both of those are completely different. Those are different labels, and they don't interact with each other. You have to have individual permissions for the label for the object that you'd like. Sometimes we use a hybrid, which is kind of a combination of both, so that each individual level can have isolated groups within it. Compartmentalization at the hierarchical level. So in a hierarchical level, I can access things that are in a lower level than mine, but inside my my level that I'm at, if I'm at the private level, I can't see the individual items within it. So mandatory access simply uses labels to describe both the subject and the object, and those have to be matching. Our next two models sometimes can get confusing. They both have the exact same acronym, Rule-Based and Rolebased, but they're completely different. So it's hard sometimes if you see a RBAC, Role-Based, Rule-Based Access Control, to know which one you're talking about. It's always good to make sure you're explicit for things that are confusing. A rule-based access applies global rules to all subjects. Everything gets treated to the exact same rules. We simply call this the restriction or the filter. We can choose to add or allow or block access to all users individually, but we can also choose to say individual items like this IP address is open to everybody, this IP address is closed to everybody, this one is available to only this other IP address, but it is simply a subset of rules. Generally, we call them if-then options. If it is between 8 and 5, users can access their data. If it is an email attachment, its size is limited to 20 megabytes. Different if-then rules. We also use these kind of rules on routers or firewalls, so you've probably seen them before. The other RBA would be called role-based access, which is where your individual access is based on your role or the group that you are in. I can be in the admin group, and therefore my permissions are assigned to the role not the user specifically. This is easier to administer because if somebody is an administrator, all I have to do is add them to the administrator group and suddenly they have all the permissions that administrators have. However, it's also much more difficult to fine-tune or use very specific, this file is only accessed by other people. If you're going to say every file is accessed by all administrators, and I'm an administrator, I can access the file. So now you might have to grow individual groups for Project A or Project B to limit access in those situations. The example here is the individual loan officers are all in the loan officer role. As an access of a loan officer role, you have access to both server 1 and server 2. That's how easy it is to be able to do role-based access because you're often identified by a job description or a project. Our last two control models that we're going to talk about are attribute and risk-based. An attribute-based access means that the rules can include multiple attributes. So it's a little bit more flexible than just basic rule-based. For example, in software-defined networks, we can use attribute-based to say specifically, this user can have this rule or perhaps this rule. It's also generally written in plain languages, so it allows the managers to access the WAN if they're using a mobile device, and it's very easy to understand when you are writing your rules. The last one is a risk-based, and this one's really kind of specific because it uses machine learning and AI to figure out what the risk is before it grants access. So using machine learning, using predictive or predictive conclusions based on the previous activities, we can actually look at the environment and the current situation and make the decision. Is this an appropriate thing for this user to be accessing this piece of information? Does it seem kind of weird? Is it something that might want to get some extra information before we just give them permission? These are things like multi-factor authentication or perhaps compliant mobile devices. When you do multi-factor authentication, it's going to say, okay, you want to get into this account. How are you going to do that? You're going to go find your phone and you're going to go type in the code that I'm going to email to your phone or I'm going to send a text to your phone just to make sure, just to give a little bit of assessing the risk. Now, if you've already logged in from this computer multiple times, we might have that checkbox that says, keep me logged in, and we're okay. This is an IP address you log into frequently and we're good and it's not a problem. But if you're in a different country, a different state, and you're trying to access it, the machine learning can kind of look at that and go, that seems a little bit odd. Maybe we need to add some extra permissions in there, some extra options, check a couple of other things. Maybe we need to notify someone to just check, are you supposed to be accessing this situation? The last part of this section is just simply describing the difference between discretionary and non-discretionary. We've already described discretionary access as allowing owners or data custodians to make decisions. Permissions are usually included in your ACL or your access control list, and the owners are the ones in charge of easily changing permissions for their products. Anything that is not discretionary is now called non-discretionary. And non-discretionary access is designed to allow administrators to make changes that affect the entire environment. It is not specifically the owners or data custodians that are in charge anymore. Non-discretionary access usually involves a static set of rules for the entire environment, and they aren't usually focused directly on user identity. They might be on a role or on the rule-based or different types of things therein. So every model that we just referred to is either a discretionary model, the first one we talked about, or non-discretionary, meaning that an administrator or a security person needs to be making those changes that affect the environment rather than the data owner. At this point, we're going to go ahead and explain two different ways to implement your authentication system. First on the internet, and then next on your internal network. On the internet, we generally use a concept either called SAML, the OAuth, or the OpenID. So we're implementing a single sign-on or some way to log in either with a login token or some other information. Remember, when we talk about authentication, we want to use both authentication and authorization. We need to find out, are you who you say you are, and do you have permission to be doing what you want to do? The SAML, or Security Assertion Markup language, is generally an XML-based standard, It's designed from OASIS, the Organization for the Advancement of Structured Information Standards, and it provides a principal, a service provider, and an identity provider. The principal being the person, the service provider, and the identity provider. So the principal is going to simply say, I want to have permission to be doing this. And the identity provider is going to verify their identity, and the service provider is going to verify that the service gives them authorization. So the responses from SAML are going to give you authentication, you are who you say you are, and authorization, you have permission to be doing what you want to do. Finally, there's also some extra pieces of information that we call attributes, just maybe your name, maybe your email, other pieces of information that just describe who you are. So first, the OAuth, or OAuth 2, is the open authorization. It is an authorization framework. Remember, authorization determines if you have permission to do something. IETF, the Internet Engineering Task Force, describes how we want to do the actual information authorization here. And what we do is we pass some information using APIs and obtain a token from the identity provider that says, I am John, I am Cheryl. And therefore, when I say that I am who I am, I go ask, can I have permission to do this thing? And it says, yes, Cheryl has permission to do that thing. And then we log it and we keep a track of it. OpenID is an authentication standard determining if you are who you say you are. We generally call OpenID a decentralized authentication. Back in the olden days, we used to have to store individual logins and passwords for every single individual user, all centralized in a central database, which was obviously a little bit dangerous, keeping logins and passwords there. We can use the OpenID standard to be able to get the credentials to determine your identity. When we want to do our third-party connections, like logging in with your Microsoft AD account or logging in with your Facebook account or your Google account, we use the OpenID Connect, or the OIDC. And the OpenID or ID Connect is the standard that we use with OAuth. So OAuth, or the Open Authorization, work together, and you end up getting this token, which is a JSON token, JavaScript object notation, JSON, and it's a web token. So you get the token, and it says, I'm going to log in. So I'm going to say I want to log in with my Microsoft AD account. And it says, okay, fine. Sends me over to Microsoft's AD account, and it says, log in with your information. I log in, Microsoft verifies it, and then they return back to the app a token. That token says, I, Microsoft, verify that Cheryl is who she says she is because she logged in with the right credentials. Now you can go ahead and treat her as though she is Cheryl because I verified that that's who she is. And then you can check authorization using OAuth to make sure that she has permission to be doing whatever she says she wants to do. This is a nice, convenient way of limiting the amount of extraneous emails and passwords that you have running around in the internet. You can just log in with your Microsoft account or your Google account or your Facebook account to be able to verify your identity without having to store your local name and password on the site that you are accessing. That means that the site does not have to be responsible if they have a data breach for losing your personal ID and password. It also means you don't generally have to store an extra password in that list that you're not supposed to be writing down. So the OpenID Connect is the one that uses third parties like Google and Microsoft and Facebook, using the OAuth to verify that you have permission to be doing what you say you're going to do. OpenID is verifying that you are who you say you are, your identity, your authorization, because those are two pieces of information we need to do to make sure that everything is ID'd and authorized when you're accessing the internet. When you are implementing authentication on internal networks, most people are going to be using Kerberos. So I'm going to explain that last. Your Radius is the remote authentication dial-in user service, which verifies authentication and authorization using UDP, which to encrypt the password. The Terminal Access Controller Access Control System Plus was designed to actually be an improvement on Radius using port 49 created by Cisco, both of which are still in use, but most of the time we're going to be using Kerberos. When we authenticate on an internal network, we want to make sure that we implement the AAA protocols. We want to authorize, we want to authenticate, and we want accounting. We want to have some sort of an audit trail or a log to verify everybody who's logged in. This is used when you access your VPNs or your internal networks. So, Kerberos. Kerberos uses a ticket granting system or a ticket authentication using a third-party service. So, we have created what's called a service ticket. I am on my client, and my key distribution center, or my DC, provides the tickets. I go send my information to the ticket to get a ticket granting ticket to authenticate what I can do. So first things first, I'm going to go log into my distribution center and say, hi, I'm Cheryl. And they say, cool, we believe that you're Cheryl. Here is your service ticket or your ticket granting ticket, your TGT, which is going to tell you that you are who you say you are. Now I have that ticket in my hand. It says, I am Cheryl. So I have a piece of paper that says, I am Cheryl. When I want to access file A, I hand the distribution center, again, my ticket granting ticket, and I say, I'm Cheryl. I'd like to access file A. And the distribution center goes through, and it says, okay, cool. I have authorized that you have access to file A because you are Cheryl, and I'm going to give you a service ticket, an ST. Then I am going to pass both my ticket granting ticket, saying that I am who I say I am, along with my service ticket that says I'm allowed to do what I say I want to do, to the server that is going to check and see if both of those are good, the authentication server, then go get me the file and bring it back. And if both of those are not good, for whatever reason there is some problem there, I can refuse you at this point and say, no, I'm not okay with that. So when I send it back, I can either hand you data or I can hand you some sort of an error saying there was something wrong with one of your tickets. The way Kerberos works is you end up getting both of these tickets, a ticket granting ticket, the thing saying I am who I say I am, and the service ticket saying I have permission to be doing what I say I want to do. Both of those come out of the distribution center, the key distribution center or KDC. It provides your tickets for you. Then I hand both the tickets to my authentication server that verifies the tickets and makes sure that they're good. By going through all of this rigmarole, you can verify authorization and authentication along with keeping an accounting of everything that I have asked for. By keeping those logs, you can make sure that people don't be getting into things that they shouldn't be getting into. Our last section is on understanding access control attacks. Most of the attacks that we're going to reference you were probably aware of, so we're going to go through them relatively quickly. We're also going to discuss some core prevention methods of ways to protect yourself from these attacks. So the first thing we need to understand is what is access control and why do we do it? The goal of access control is simply to prevent unauthorized access to objects while still providing authorized access to objects for people who are allowed to have it. We want to make sure that there's that access or availability part of our CIA triangle to make sure that if I'm supposed to be getting access to this file, I can get it. But if I'm not supposed to have access, I don't want to have it. I want it to be able to stop me. Remember, a risk is simply the possibility or likelihood that a threat will exploit a vulnerability resulting in loss or harm to an asset. So, a threat being a potential occurrence of something bad, undesirable outcome. A vulnerability is a weakness, flaw, limitation, something about your system that allows someone to break in. And an asset is anything you value. It can be a person, a place, a thing, a reputation, an idea, so on and so forth. Our risk management is simply the attempt to reduce or eliminate vulnerabilities or reduce the impact of threats by implementing controls or countermeasures. We're always aware of the fact that there is never 100% protection. The best way to do this, if you want 100% protection, is build your server and put it in a hole and cover it up and don't put any access to it. But then we don't have availability. We can't access our data. So there is always going to be a risk. You can never get rid of all of it. So you always want to be aware that as much mitigation as you can do to prevent your risks or decrease the threat, there's always going to be a chance that something bad will happen and you will have to deal with it. That's why we throw in business continuity plans and disaster recovery. So a couple of access control attacks. Access control being, how do we control who is able to access the data? So the attacks that are related to that. The big one is privilege escalation, using superuser pseudo attacks in Linux or PowerShell permissions in Windows. Generally, you want to limit any superuser permissions on a Linux machine, and you want to restrict any PowerShell permissions on a Windows machine, because those can give users more privileges than they should have. Privilege escalation is one of the fastest ways that a hacker can get into your system. If you have a Linux box running and you have everybody set up with superuser permissions, they can just superuser in and go ahead and add in a new account for themselves, go delete logs, go add files, go do anything they want. The next couple are all password attacks or attacks on passwords. Most of them you should probably be aware of, but I'm going to try to explain the ones that may be a little bit new to you or confusing. So dictionary attacks are where you use every word in the dictionary. Brute force attacks are where you start with A and then you go to AA, AB, AC, and then you literally just brute force your way through it. Spraying is essentially a brute force attack, but it's designed to handle lockouts. So if you put in the wrong password 3 times, it locks you out of the account. But you're allowed to put in the wrong password as long as you wait a certain amount of time between entering passwords. If there are 100 users in the system, I can run a brute force attack where I check A against user 1, then user 2, then user 3, then user 4, all the way to user 100. And if none of those worked, then I can go back to user 1 again and type in AA and then run through all of those. So it's designed to run the same password on all users running in a loop. If you have 10,000 users, you can easily bypass the account lockout time of a couple of seconds by not running it the same user over and over again. You're running different users with the same password to see if any of those work. Credential stuffing is where you follow the basic concept that normal people will use the same password and log in for multiple sites. So if I figure out your login password for Netflix, odds are it's probably the same password as you use for Hulu. And it might be the same password you use for Amazon. Oh, but if you use it for Amazon, I can get into your Amazon account and then I can find your emails and I can find your deliveries and I can send myself packages and I can charge them against your credit card. So credential stuffing is taking advantage of the fact that normal people probably have the same username and password for multiple sites. Birthday attacks are essentially finding 2 passwords that create the same hash. It doesn't have anything to do with the date of birth. It has to do with the fact that in the birthday joke, if you have 365 possible birthdays, 366 if you count leap year, and you have a room of 100 people, after the first 3 people, the chance of 2 people having the same birth date actually increases exponentially and it becomes very quick. So out of 100 people, if you've gone through 50 birthdays or 50 people, the odds that there is one of them that has the same birth date is actually pretty high. Rainbow tables take advantage of that logic by checking to see, hey, if I can get a hash that works, I can do a second hash and that maybe that one will work as well because maybe I'll have 2 passwords that create the same hash. Rainbow tables help you by pre-hashing the passwords. If I start with password A and then go to AA and then go to AAA and then AAB, I have to create the password and then I have to hash it and then I have to compare the hashes whether or not they fit or not. If I pre-hash all of those passwords, I save myself a step. We call those rainbow tables. They're a table of hashed passwords that are essentially all of the passwords that are already hashed for us so that we can save a step in computing time. The pass the hash, or the PTH, sends the hash rather than the password. So normally you type in a password. You don't type in a hash. You type in a password. And the password gets hashed by the client and then it gets sent off. Well, if I bypass that, I'm just going to send them the hash instead of sending them the password. And that way I can kind of bypass going through the client and allowing it to go straight into the server with the hash directly. So it's passing the hash as opposed to passing the password. This is used in the Mimikatz. So Mimikatz is the base, the underlying code behind Metasploit, which is one of the more common exploiting softwares out there. If you're not aware of it, you need to be, because it's one of those things that's going to come up in your life and you need to understand it if you're going to go into this field. The Kerberos exploit uses either the Rubens for Windows or Impacket for Android using the Mimikatz environment. So again, in Metasploit, it is designed to exploit vulnerabilities in Kerberos. So again, that ticket granting and the decision controller and the authentication server, making sure that we can exploit some vulnerabilities in Kerberos to be able to get some passwords in there. And the last one is simply sniffing, using Wireshark to sniff your password and your hash. If the client has already is passing across your username and then the hash, either as hash or as a password in clear text, and I'm using Wireshark, I can sniff that and be able to see what your password is. And the last common access control attack is simply spoofing. We are going to send you an email and we're going to send it from someone you think you know that says, click this link, it's funny. Or phone numbers. We're going to send it from a phone number you know and says, click this link, it's funny. And then be able to use spoofing attacks to get you to log in or to somehow get into permissions, into access controls. So some protection methods to protect ourselves from access control attacks. First, always try to control physical access to your systems. I know most people don't go into a database server and plug in with a keyboard and a monitor, but you can. So you always want to control the actual physical access to that. If it means your server room is in an unmarked door in the middle of your building, that's great. Just control the physical access to your systems. You also want to control the electronic access to your files. Make sure that you follow some sort of access control method to make sure that only the right people have access to the files. You don't want just every file sitting out there so that everybody can access it. When you enter passwords, you always want to hash your passwords and salt your passwords. Hashing isn't enough. You want to throw a salt in there as well. Hashing and salting passwords is going to come up in our cryptography lesson, but taking the password, running it through a hash algorithm, adding a piece of salt, so a piece of information to the password and then hashing it. So I could take the password and I could hash it, and then I could take that hashed value and add in the username and then hash that again. And then I could add in, a random key like a zip code and add that and then hash it a third time. Following that salting is going to be really, really hard for someone to unhash or to be able to figure out from the hash the password directly. Even if they get the hash directly, they may not know how to get the password. When you are using passwords in user interface, always mask your password. That's the part where you get to see the stars instead of actually seeing the letters as you type them. Yes, we all end up clicking that little I because we're not sure if we're typing it correctly, but in general, you want to use password masking. Multi-factor authentication should start to be the standard. Everybody should just accept it. It's a thing we need to do to make sure someone breaks in, they steal your password, but they have to steal your phone as well. That's getting a little bit harder. They have to be able to get into your email to be able to check multi-factor, or they have to do a biometric with your fingerprint or your retinal scan. Multi-factor authentication is going to start to be the common norm of protecting your data. Using your lockout controls. So if you've logged into the account 3 times with the wrong password, lock it out. You're done. Just go ahead and lock it out. You have to call. You have to get permission back. And if you do have to use those controls, it will help to prevent unauthorized access. You also like the idea of using a last login notification. When you log in, it should say you last logged in yesterday at 8 p.m. Did you? Did you really log in at 8 at night? Did somebody else log in for you? It's a great way of being able to identify quickly that, yes, you logged in and there was a problem there. Or no, you didn't log in, somebody logged in for you, so on and so forth. And the most important part of core protection methods is education, awareness, making sure that the users are aware of security measures. Yes, they're going to use multi-factor authentication. No, they are not using password as their password. Yes, they are going to have to go through some effort to make sure that they log in correctly, and security is aware of the roles and privilege creep and so on and so forth. So in summary, it's really important for your CISSP exam to understand all of the different access control models by acronym. You want to be able to see them and know which one is which. Discretionary, mandatory, rule-based, role-based, risk-based, and attribute-based, ABAC. So you want to be able to know what the individual ones do, how they work, and if you were to see a rule-based list of an ACL or perhaps a role-based saying, only the insurance group can access these files, what type of model is that? You want to make sure you understand your basic internet-based authentications with SAML, OpenID, OAuth 2.0, and the OIDC. Remember, using OpenID along with OAuth to be able to get authentication and authorization. Your internal based networks with Kerberos, Radius, and TACACS plus along with your AAA. You want to remember what that AAA stands for and what each of those works. And you need to understand, if you were to see a ticket granting system, is it Radius or is it Kerberos? Yes, you know which one is which. And finally, you want to be able to recognize and understand how to prevent the common access control attacks. How do I prevent privilege escalation? How do I prevent password attacks? How do I prevent spoofing? What are the things that I can do in my company to protect my company from these type of access control attacks? Thank you for watching this lesson on the CISSP Chapter 14 on access control. Have a great day.